Hello, welcome back. We're going to do 4.6, which is arithmetic sequences, and this is part 1 of this lesson. So this is going to start off with some vocabulary. Let's talk about what a sequence is and a term. So a sequence, we're going to write down that is an ordered list of numbers. So sequence, ordered list of numbers. So for example, it could be like 1, 3, 5, 7, 9. So that is an example of a sequence. A term is each number in a sequence. And terms can have positions, so these have positions. So what I mean about that is if these are your numbers, the terms, your first term is a 1. Your third term is your 5. And your fifth term is your 9. So that's what I mean about position. So if I said find the 6th term, it means find the 6th number in that sequence. All right, arithmetic sequences. Let's go down to the core concepts here. In an arithmetic sequence, the difference, here we go, difference between each pair of consecutive terms, that means like between the first term and the second terms, is the same. So the difference is the same, and we call that a common difference. Also, the common difference, we designate that as a D. All right? Each term is found by adding the common difference to the previous term. So this example was 5 plus 5 is 10. 10 plus 5 is 15. Another thing is your common difference if you want to add something. Arithmetic sequences mean we have an adding or subtracting pattern. So if I look at the one I just wrote up here, the pattern is I'm adding 2 every time. Another example could be 12, 6, 0, -6, -12. And this one, my common difference is subtract 6 because between each term, I am subtracting 6. Okay, so let's get into some of these examples. We're going to skip this section right here until the next video. So example 1, write the next 3 terms of the arithmetic sequence. So the first thing you have to do, is we need to find the common difference. Okay, so find the common difference, which is that D value. So if I look here, how do I go from 7 to -14? I'm subtracting 7. From -14 to -21, subtracting 7. Now they're telling me it does have an adding or subtracting pattern. Okay, so it is telling me that right now. Another way you could do, if you can't see it on your own, is if you take this the second term and you subtract the first term, that will tell you your common difference. So, for example, I could put -14 minus -7, and that gives me -7, which we saw that is the same. So when it says write the next 3 terms, I just want to continue that pattern. So what is -28 subtract 7? That is going to give me -35. And then what's -35 subtract 7? If we continue that pattern, it's -42. What's -42 subtract 7? It's -49. So the next 3 terms are these numbers right here. All right, go ahead and pause the video and do the next 3 on your own. When you're done, go ahead and press play, and I'll tell you the answers. All right, now that you're back, what you should have had for the first on your own is 36, let's see, 48, and 60. This next one is 1.8, 2.2, 2.6, and this last one we're subtracting 1/4 every time, which gives you 3, 2 3/4, and 2 1/2. All right, so let's move on to example 2. It says graph the arithmetic sequence, and then what do we notice? So Remember, these are the individual numbers. So I like to think of this as what position and what is the term value. So what's the term position and the term value? So we're going to make an X and Y t-chart here. So I have the numbers 4, 8, 12, and 16. 4 is the first term position, and then 8 is the second one, 12 is the third, 16 is the fourth. So you can make a table of values if you want, and now we are just going to plot these as ordered pairs. It's sort of like being an X and a Y. So 1 comma 4 is right here. 5, 6, 7, 8, 2 comma 8, 3 comma 9, 10, 11, 12, and 4 comma 13, 14, 15, 16. So I have those points plotted. And then it says, what do you notice? What I notice is these go, it looks like in a linear fashion, a linear pattern. So I'm going to say, what do I notice? I'm going to say that they look like they're linear. Looks linear. Now, it should. If it's an arithmetic sequence, if we have an adding or a subtracting pattern, that is a constant rate of change. And the constant rate of change is that slope. So if you ever see that in a graph, then you know it's arithmetic because it's linear. Arithmetic sequences, right here, arithmetic sequences are linear. Okay? If you ever graph one and it starts curving, you didn't do it right. If it's telling you it's arithmetic. Okay, example 3. Does this graph represent an arithmetic sequence? First, if I look at it, it looks linear. So on that point, I could say yes because it looks linear. But let's double check. We're going to make a little chart here, and I'm actually going to do a horizontal X and Y. 1, 2, 3, 4. I'm going to write these ordered pairs. 15, 12, 9, and 6. And I'm looking for that common difference. I'm looking for the common difference. Okay, so do I have an adding or subtracting pattern? So that means I'm looking for an adding or subtracting pattern. If it has an adding or subtracting pattern, it's arithmetic. So from 15 to 12 is minus 3. 12 to 9, minus 3. 9 to 6, minus 3. You have to check each of them because one of them might be different. So because they're all the same, I would say yes, and I can say because it has a common difference. Now, if it wasn't on line and it's on your paper, you could say it has a subtracting pattern. I'm okay with that. It has an adding pattern. Great. You can even say that it has a common difference, which is D equals -3. All right, so those are the only 3 examples we have in our notes. Go ahead and do these next 3 on your own, and then I will tell you those answers, and then you are done with this lesson. All right, welcome back. Graphing these next ones. This is question number 4, so this would be 1 comma 3, 2 comma 6, 3 comma 9, 4 comma 12. This next one, this question number 5, is 1 comma 4, 2 comma 2, 3 comma 0, 4 comma -2. Oops, I probably should have done an XY axis there, but that's what it would look like. All right, and then on your own, number 6. All right, sorry, I just got interrupted with a phone call. That's sort of fun. I don't know if I'll edit this out or not. I'm going to try. Anyway, on your own, number 6. I can tell if I wanted to connect these, like these two go, and then boom. So remember, a constant rate of change is like your common difference. So if I know I go up 1 and over 1, up 1 over 1, I mean it goes here, up 1 over 1, up 1 over 1. I notice that these 2 points right here don't fit a linear pattern. So visually I can tell it's not. But let's just double check with a table of values again. So right here, X and Y, we have numbers 1, 2, 3, and 4. We have our 4 terms. and those term numbers are 2, 4, 7, and 11. So I'm adding 2, adding 3. Right there I stop. I mean, I could say, oh, this is adding 4, but as soon as you see one that's different than the other, you stop and say, no common difference. Also, if we're in person and you're on a test, you can say there's no adding pattern, there's no subtracting pattern. Okay, there is a pattern here. You're adding one more every time, so from 2 to 3 to 4, it'll probably go to 5 after that, but it's not adding the same amount every time, so it's not arithmetic. So that is our lesson for today. Best of luck to y'all. If you need help, reach out to me, and I'll see you here next time.